You've got one in your kitchen right now, and you probably use it dozens of times a day. But have you ever really stopped to think about what's going on inside your refrigerator? Today, we're going to pull back the curtain and decode the magic of one of the most important appliances in our modern lives. I mean, it seems so simple, doesn't it? You plug it in, you shut the door, and stuff gets cold. But how? How does a room temperature box just start making cold? What is actually going on in there to make that happen? Well, here is the big secret. The one thing you need to remember through all of this. Refrigerators and air conditioners don't create cold. They're actually heat movers. Their entire job, their only job, is to grab heat from inside the box and dump it outside. That's the key. Okay, so if it's all about moving heat, how in the world does that actually happen? Well, to understand that, we need to meet the star of the show. Say hello to our little hero, the refrigerant. This is a special kind of fluid that has a super low boiling point. And its entire purpose in life is to absorb heat in one place, travel, and then release that heat somewhere else. It's on a constant mission, a nonstop journey, all to keep your food from spoiling. So what does this journey look like? Well, it's a surprisingly simple and elegant 4-step cycle that just goes round and round 24/7, all happening inside a sealed system of pipes. All right, so here are the 4 stops on its journey: the evaporator, the compressor, the condenser, and this little thing called a metering device. Let's walk through what goes down at each and every stop. Okay, first stop, we're inside your fridge in what's called the evaporator coils. Here, that cold liquid refrigerant is basically a heat sponge. It soaks up so much heat from your leftovers and your milk that it actually starts to boil and turns into a gas. And that's it. That's the moment the cooling happens. All right, so now we've got this refrigerant gas. It gets sucked into the compressor. You know that humming sound your fridge makes? That's usually the compressor kicking on. And its job is to squeeze that gas, like really hard. And when you do that, its pressure and its temperature go way up. So now we've got a super hot, high-pressure gas. Now this super hot gas, carrying all the heat it just stole from your food, travels to the condenser coils. You've probably felt this. It's why the back or the bottom of your fridge feels warm. This is where it dumps all that collected heat out into your kitchen. And as it gets rid of the heat, it cools down and condenses back into a liquid. Okay, last step. We have this high-pressure liquid, and it gets forced through a tiny little hole. Think of it like the nozzle on a spray can. And when it comes out the other side, whoosh, the pressure just plummets. And here's the cool part of the physics. When you drop the pressure that fast, the temperature crashes right along with it. So now, we're right back where we started. A super cold, low-pressure liquid ready to go back inside and grab more heat. So there you have it. Evaporate, compress, condense, expand. That's the whole cycle. But, engineers, they love their charts. How do they actually see all of this happening at once, with all those changes in pressure and heat? Right, they need a map of the journey, something that tracks our little refrigerant hero at every single point in its cycle to make sure everything's running as efficiently as possible. And this is what they use. It's called the pressure enthalpy chart. And I know, it looks kind of terrifying, right? So many lines, but trust me, it's not that bad. The best way to think about it is as a treasure map for our refrigerant's journey. Seriously. To read any map, you just need to know 2 things. On this one, the up and down axis is pressure, and the side-to-side axis is something called enthalpy, which is just a fancy word for total heat energy. So just think, up and down is pressure, left and right is heat. That's all you need. Now let's trace the path. All right, look here. This flat line at the bottom, that's step 1, evaporation. See how it's moving from left to right? That means it's gaining heat. And because it's staying at the same low level, the pressure isn't changing. So, gaining heat at low pressure, that is exactly what's happening inside your fridge. Now, watch this. Step 2, the compressor. Boom. Look at that line just shoot up and to the right. What does that tell us? The pressure is going way up and the heat energy is going way up. It's a perfect picture of that gas being squeezed. Okay, now we're at the top of the chart for step 3, the condenser. The line is now moving from right to left. That means our refrigerant is losing all the heat it picked up, and it's all happening at that constant high pressure, getting ready to become cold again. And to finish the loop, we have step 4, the expansion. See that straight vertical drop? That shows a massive decrease in pressure, going straight down the chart without much change in heat. And just like that, We're right back at the beginning, ready to do it all over again. See? Not so bad once you break it down. Now that we can actually read the map of this journey, the next question engineers are always asking is, can we make it even better? Can we make it more efficient? And the answer is a big yes. One of the clever ways they do this is by adding a component called a subcooler. It's a simple idea, really. Its only job is to make that liquid refrigerant even colder right before it goes into the evaporator to start its work. So what's the point? Why the extra step? Well, it boils down to two awesome benefits. First, it increases the refrigeration effect, which just means you get more cooling power. And second, it makes the whole system more energy efficient. More cooling for less electricity. It's a win-win. So when you really think about it, that whole cycle, from grabbing heat out of your food to dumping it into your kitchen, is just this constant, powerful journey happening inside a closed loop of pipes. It's not magic, it's just some really, really cool physics. And that kind of makes you wonder, doesn't it? This whole principle of moving heat is everywhere, not just in our fridges and air conditioners. So now that you can read the map of refrigeration, what other invisible cycles do you think are humming away, powering our world right now?